Okay, for the second part of P4, we're going to look at a few things regarding lines and also working with the graphing calculator. And we're first going to look at how to draw a graph using a graphing calculator. And the first step is always going to be to rewrite the equation in the form y equals and then something with x. Okay. In some cases, we might be given the equation already in that form, which would be nice. Okay. In some cases, we might have to solve. So as an example, if we were given a line that's in the general form or standard form, that's not something we can put in the calculator, because when we hit y equals, where we put equations into the calculator, okay, it has to be just that. It has to be y equals. Okay, so in order for us to deal with that line, we would have to solve for y. So I did that down here. I solved for y. I subtracted 2x from both sides. Okay, and I wrote 5y equals negative 2x plus 4. And then I divided by 5, and I got my final answer of y equals negative 2/5 x plus 4/5. Notice when we do that step, we're dividing everything by 5. Okay. And now that it's in that slope-intercept form, now we can go ahead and put it in the calculator. I also picked this one so that we would make sure we're clear on how to deal with fractions. If either of these are a fraction, or any equation you write has a fraction in it, you need to make sure you put it in parentheses. Use your divided by key. So negative 2/5 x plus 4 divided by 5, or 4/5, would be the way I'd want to type that into my calculator. Right. And then step 3 says select an appropriate viewing window. And a lot of times when I do the first graph, if I'm not 100% sure what it looks like, in this case I know it's a line. I know it has a y-intercept of 4/5, so it goes through pretty close to the origin. Okay. What I generally do is use a standard window. Okay. And a standard window looks like the one I have on the next slide here. Okay. When you go to your window, it looks like this: negative 10 to 10, negative 10 to 10. It just goes 10 left, 10 right from the origin, 10 down, 10 up from the origin. And you can either type that in if you want to, or your calculator will do it for you if you just hit zoom, which is right in the middle, zoom, and then pick number 6. And you can just type in 6 if you want to too. You don't have to scroll down to it. You can just hit zoom 6. And that'll give you a standard window of negative 10 to 10 and negative 10 to 10. Never mind those little dots I have above there. We're going to get to those in a little while. But for now, okay, we can see that it is a line. It crosses the y-axis at 4/5, like we expected, because that's the y-intercept of this line. Okay, and if we were to go from point to point, we counted down 2 and over 5, down 2 and over 5, okay, which is our slope. Okay, we'd get to another point that's on that line. Okay. All right. When we have some work time in a few minutes too, if there's anything that your calculator is doing that doesn't seem like it's the same as mine, okay, any trouble you're having, okay, I'll check that out at that time as well. One thing that you might have to do sometimes as well, depending on what the line looks like and what the y-intercept is and so on, okay, you may have to adjust the window. Like for instance, if I were to say that the y-intercept instead of 4/5, if I said it was 50, and I hit graph, I wouldn't see anything. Okay? Because in this window, the graph is way up here. It's up at 50 where it crosses the y-axis, and it goes down 2 and over 5. We never see it in this window. Okay? So what we may need to do is make an adjustment knowing that, and go back to our y-max and maybe make that up to, say, 75. Okay? Because I know I'll at least see the y-intercept at this point, because I know that's 50. And if I make that 75, then maybe I'll see something in the graph. And of course we do. Okay, there's the line. It shows up where we thought it would be. Okay? Okay. Questions so far? All right. What we're also going to look at today is dealing with parallel and perpendicular lines. Okay? So I want to look at the two rules first, and then we're going to see some problems that we're going to be asked to look at and try. First one is our rule about parallel lines. So if lines are parallel, their slopes are equal. Hello? Hello? So Hello? Yes. Sure. Okay. Larry, you gotta go, I guess, on the main office. That's your stuff. Okay, so ultimately these two lines are going to be parallel, okay, if their slopes are equal to us. So I put a couple examples on there. If they're both in slope-intercept form, pretty easy to tell because the slopes are right there in front of you. Okay, if they're not in slope-intercept form, they're like in standard form, you might have to solve for y, and then you can tell whether they're parallel or not, if that were the question. Okay. Also, if the lines are perpendicular, then the slopes are opposite, which notice I have a little plus minus here. They have to be opposite signs, and they have to be reciprocals. So in order to be perpendicular to each other, those slopes have to be opposite and reciprocal. So my example over here is I have -1/2 and 2. Okay, those are perpendicular lines because the slopes are exactly that. They're opposite and they're reciprocal. Okay. I put another example down here on the left-hand side, and I might ask the same thing. Are these two lines perpendicular? Okay, well, they're reciprocals, but are they opposites? No. So the answer would be no in this case. If we were to graph those two, they would not be perpendicular. They have to be both. They have to be opposite and reciprocal. So let's take a look at a typical problem that we're going to have to tackle today. It's going to be something like this, where we have a point, and we have to find the equation. So just like we started out today, if we're going to find the equation, if I were you, I'd write down the point slope form. And notice that they gave us a point, so that means that 2/3 of our issue is already taken care of. We already know the point, so we can go ahead and put that in there right now. The key question though is, how did I find the slope? Okay. I put my 2 and my -3 in for x1 and y1. Okay, and they told us that the line that we're dealing with is parallel to this line. Well, this line is not in slope-intercept form, so what I need to do is put it in slope-intercept form. So hence I subtracted 4x, and then I divided by 5, and I got the equation for that line in slope-intercept form. And again, how did I know to put -4/5 there? Because I wanted a line that was what to the original line? It's got to be parallel. So therefore, if I know this one has a slope of -4/5, then what does mine have to have? -4/5. It's got to be the same. Okay. Question so far? Okay. How much different a problem would that be if I asked you to do it for a perpendicular line? Would I really do much different? No, it's really the same issue, except for when I do that on mine over here. Again, I wrote down my point slope form, and then over here I solved the equation that was given for y. One thing I want to point out in here, remember if it's 2x minus y, when we do that minus 2x part, we still have a -y here. Okay, so that means we're not done. We got to get rid of the negative, which is really -1. So hence I divided by -1, and I got y equals 2x minus 1. But remember, in this case, instead of putting a 2 in there, okay, we don't want them to be parallel, so we're not going to use 2. We're going to use the opposite and reciprocal, which is -1/2, and that's why I have -1/2 here for my slope. Okay, and notice I put my point in as such, my -4 and my 5, and so my final answer is that. Now you'll notice that I circled these and I didn't do anything else with it. Okay, because anywhere in the directions does it say to put it in slope-intercept form? Then don't. Okay, why take the chance on solving for y here and getting something wrong when you don't need to? There's really no good reason to do that. Okay, so just leave it just like that. Okay, call it good. Okay, you don't need to do anything more with that. That is the answer. Okay.